Hello and welcome to week one. This week we're going to be talking about wind and solar. So this video I'm going to talk to you a little bit about solar. So when you think about solar energy, most of you are probably thinking about what we have in these pictures here. We're thinking about solar panels. Solar panels or solar photovoltaics create electricity directly from the sun. So this is a panel here that's going to create electricity when the UV lights from the sun hit it. These can be installed on your roof. You might see them around. You might have them currently on your house right now. But they can also be on a ground mount. You might have a large scale installation where you might have commercial or industrial size installation. When you're working on your projects, I want you to be sure you're clear whether you're talking about a residential systems or commercial systems. Now, solar photovoltaics are just one type of solar ways to use the sun for energy. So I want to talk to you in this video about some of the other ways, because solar PV is traditionally the one we all visualize when we talk about it. Solar thermal is another type of energy that we can get. We can use energy from the sun. And one type here is using solar thermal to make solar hot water. So you may have seen these panels on someone's roof. They're a little bit different. So there's some tubes in here. And they go up, they're typically on your house and they go up on your roof. And in these tubes we can run water to make the solar hot water, but traditionally we use a glycol solution. Glycol is an antifreeze, just like you would have in your car, which does exactly that. If we live in the northern hemisphere, we have the chance of freezing. And it would be really terrible to wake up in January morning and not have hot water because our solar hot water heater froze. So we would use a glycol solution in here and then have a heat exchanger to make the hot water. With this type of system, you would still have a big hot water heater storage tank, just like most of us do traditionally in our basement or so on. With this design, you might have your hot water heater, your tank, closer to the roof, closer to where you're creating that hot water. It's funny to think hot water accounts for about 15% of your energy use, and most of us put our hot water heater where? In the basement, where it's the coldest part of our house. Why we do this, there's really no rhyme or reason other than it's just out of the way, but moving where we put our hot water heater and using the suns, we can save a lot of energy on that. But this is how we can use solar thermal in our home. But we can also use solar thermal on a large scale for power plants. So you may have seen some examples of these guys. I think there was a Bond movie where they had something that happened here, and also the movie Sahara. So this is a solar power tower. So we would have lots of mirrors reflecting the sun's light to a central location. And in the central location, we would have a salt or a oil or something with a very high heat capacity. We know water boils at 212 degrees Fahrenheit or 100 degrees Celsius. We're using some kind of fluid or material that has a higher heat capacity that can get much hotter. So the advantage of this type of production from the sun, energy production from the sun, is that we can store heat. We can store heat very, very easily. We cannot store electricity very, very easily. So the advantage here is we can store that sun's rays here in that power tower and use it whenever we want. So what can we do with that heat? Just like most of our energy or electricity production, once we have heat, we can make steam. Once we have steam, we turn a turbine and create electricity. So that's how most of our energy sources we create electricity, is turning a turbine. So with that stored heat energy, we can use it whenever we have demand on our electricity. This is another type of solar thermal. Instead of having the mirrors reflecting, we're using this parabolic trough to direct the sun's rays into this tube. And this tube, again, is going to carry something with a high heat capacity like an oil to a central location, and then we can use that heat whenever we want. Here's some other examples of the solar thermal. And here's a picture of a solar thermal with a PV system. So with the solar thermal, we are not creating electricity, we're just creating heat. Another type of way to use the sun for energy is through passive solar. There's a lot of great designs of using passive solar when you're designing a property, a home, a classroom, anything like that. And that really goes into the initial design of your property. So because we live in the northern hemisphere, when we design our solar system, we want our system facing south, regardless of whether we want passive solar or PV or solar thermal. For us in the northern hemisphere, the sun is always south of us because we are above the 23-degree Tropic of Cancer. So that means to us the sun always appears south in the sky. So here are some examples of where they're using south-facing windows to reduce lighting costs. And sometimes you can even reduce heating costs. So in the winter you can bring in more heat to help heat the home or property or so on. This works especially well in classrooms because when are schools usually in session? Especially K through 12 schools, usually between 7 and 3 when we have the most amount of sunlight. So we can reduce our energy use, our lighting use, by taking advantage of passive solar for daylighting. And the final type of solar I want to talk about today is called building integrated solar. And here's some really cool examples of some building integrated solar. And this is just using the existing building materials or the existing building to put solar on it. So rather than putting solar panels on top of the building, we're actually using it as a building material or integrating it into the building itself. So here's an example of solar windows. Here's an example of putting PV, some photovoltaic cells in an existing atrium. So we're still kind of using the building, the light that we want, but we're also collecting some of the electricity coming through there. So I mentioned solar windows, and that's kind of a cool new topic that people are interested in. It is possible to have solar windows. The efficiencies are a little bit lower, quite a bit lower than you would with a PV panel, but you can put in windows that harness some of the sun's energy into electricity. And you can also have solar paint, where you're using a special kind of paint to harness some of the electricity coming, or some of the energy coming from the sun, and convert it to electricity. Why don't we see this a whole lot? It costs a lot of money and it's not very efficient. And my last point I want to make about solar today is efficiency. As I mentioned, the solar windows, they tend to be about 8% efficient. The solar paint, less than 5% efficient. One of the problems we hear with solar is it's not that efficient. Well, currently the solar panels that you can get on the market, any of these, tend to be about 15 to 25% efficient. What does that mean? Of all the energy hitting that panel, that space, about 20-25% of that is converted into electricity. It's not a whole lot, but when you think about it, compared to other traditional combustion energy sources, the highest you can get from combustion is about 45-50% efficient. Additionally, how much do you pay for the sun? The sun fuel cost is free. When you're driving your car is only 10 to 15% efficient. So of all the gasoline you put in your car, you're only converting about 10 to 15% of that into useful energy to get you somewhere. So I wanted to leave you with this figure right here from NREL. This is the current best research cell efficiencies. So as you can see, the highest efficiency solar panel right now today, it's kind of hard to see, is here at 47%. As I said, the commercial panels that you would buy if you were going to go with the solar company today, you're going to be in here around 20%. These are not commercially available right now. These are the best research cell efficiencies at the moment. But as you can see, over time, they're getting a lot better. But if we compare that with traditional energy sources, and we remember that the cost for the fuel is free, and there's no carbon emissions, solar is really a great way to go. So I hope you enjoy this week on wind and solar, and I'll talk to you soon.